Hi everyone, welcome to Spartans Summit. We'll just give a couple of seconds more for people to join in. Good afternoon, good morning, good evening to everyone who's joining in. Let us know in the comments where are you folks joining in from. We'd love to know that. Just so that we've got Dubai here. Hi, Germany, awesome. Delhi, Pune, Hyderabad, India, Gurgaon. So I can see a lot of folks from Sri Lanka, Greece.
Greece,
Interesting. Awesome.
Germany, nice.
Yes, Portugal. So Sai and Srini, we have folks joining from across the globe today. Awesome. Great.
Nice.
Thank you so much, everyone, for joining the Spartan Summit. I am Kavya, and I'm very excited to kick off this session on one of the most transformative areas of AI, which is AI agent powered LLM applications. AI powered applications are evolving fast, but building and testing them at scale, that's where the real challenges lie. Today, we have two industry experts, Srinivasan Sekhar and Sai Krishna, both directors of engineering at Lambda Test, who are here to give us a live hands on demonstration of how AI agent architectures work in practice. And that's not all. Srini and Sai are also core APM committers and they wear multiple hats within the open source community at large. They've been, working in this space for more than a decade, and I'm sure that today's session is going to be an amazing one. They'll walk us through live implementation of AI agent architectures, practical testing strategies of LLM applications, and real world insights from their extensive experience. And the best part, the session is fully interactive, so keep your questions ready. We'll be answering those questions towards the end of the session. And before I hand over, just want to quickly let the audience know that we are also running a social media contest. So make sure that you're sharing the learnings of your from the sessions on social media. You can use hashtag Spartan Summit 2025. The top three winners will get a voucher. And please drop your thoughts in the chat or use the reaction emojis to show some love for our speakers. And stay tuned for the Q&A sessions towards the end. Srinivasan and Sai Krishna, let's get started. Over to you both.
Thank you. Thank
Yes.
you,
Thank
Kavya.
you,
Thank you
Kavya.
so much.
Yeah.
Awesome. I think we don't want to go into intro. Kavya has like given us a very good intro. So let's straight jump into the topic today about the agents, testing them. So is testing a right word for agents? So Srini, do you want to share your screen, Srini?
Yep.
Okay. So before we get into agents, I think there are certain things that we really want to understand over here is basically what is RAG, right? So basically, RAG in the space of RAG, the AI model looks up for a relevant document or a data before generating a final answer. So let's say, for example, if an employee asks, "What's a policy for remote work?" Right? So basically, what the system does over here, the system would basically retrieve the exact policy text, from a specialized database or somewhere where the information resides, and it uses that text to craft a precise, up-to-date answer for us. Right? So if you look through, and this entire process in a very high level is what exactly RAG happens. So let's deep dive into the entire RAG process, right? And how things are retrieved and stuff. So if you look through this entire diagram over here, yeah, that's good, great. So we have something called as additional documents. So consider now, you've asked certain question, and the answer resides, within your organization, right? The context is within your organization. So there are certain documents which might hold this information for us. So you would typically want to give that documents into these embedding models, and every LLM large language models have their own embedding model. So we'll come to that when we see the live application demo. And then what these embedding models would typically do is it will take these documents and it's going to chunk them. Now, what is chunking? So if I have to put it in very simple terms over here, so consider this additional document. So let's consider one PDF, right? Which is like about 100 pages. And what this chunking, the chunking is basically a process where this one document with 100 pages is going to be broken down into tiny, tiny chunks, and it will be kept into a vector database. So start imagining this way, right? So once this process is done, if you go into this vector database, so basically you will not see one document, but you'll see, like, let's say you've chunked 100 pages of one document into 10,000. So meaning that you'll see 10,000 chunks. So you'll have to actually say 10,000 entries into this vector database. And then comes our query. Query is nothing but what? So query is nothing but, in today's world, I mean, we all use ChatGPT, right? Most of us. So what would typically do? You go and you ask ChatGPT, hey, I want to know something about this, that, or write me a poem. So that's basically a query then. So now this query gets encoded, gets into this embedding model. And what this embedding model will do, it will basically do a similarity search for us. Okay. What will it search with? Right? It will do a similarity search with the vector database, because now inside the vector database, our information is like chunked into 10,000 chunks, right? So what it will do is, based on the query that you're asking, it will go fetch some similar documents. Okay. And that's what you would see, those three letter boxes down right after the fifth pointer. And it would basically get your chunks. And again, this is configurable, okay, whether you want the top 5, 10, and things like that. So it will get your chunks, and it's going to take the query, which is what you asked for, okay, and then it's going to create a prompt, okay. Now, what is this prompt? Again, we'll go back to GPT. So if you go to a chat GPT window, you'll see a system prompt, user prompt. So it's basically you're trying to tell that, hey, I've got these information, this is what you want to do, and etc., like a system prompt, right? And what would we typically do is, you would typically take that query, the documents, and the prompt, and we'll give it to the large language model. Okay. Now the large language model is going to do its magic, understand, etc., and then that's how you get a response basically out. And that's where you ask anything, you'll actually see a response out for us. So this is basically how a RAG process, completely works, right? But why is it why is this RAG process really matters to us, right? Because RAG basically, I could put it this way, right? It allows the AI to tap into external sources instead of relying solely on whatever is trained on. Okay. So if you see sometime back, if you go through GPT again window, if you have noticed at the bottom of it, it will tell, hey, I'm only able to give you answers until 2021. I only trained until that, right? So it's a constrict resource for us. So suddenly all of these AI systems could connect, to multiple spaces, right? It's just not into those trained databases. And that's where what happens is, now our agentic space come into play, because there's a restriction, right? Because I already put a but over here, because it can only gather information or give you a response based on the documents that what we have. But I need something more, right? I also want to, because this is very, very focused. I'm telling do this, it'll just do this. It'll just follow those steps, right? But I just don't want that. I also want to see how I can possibly get my response, just not from this additional documents, but possibly spread somewhere else also. Right? And I think that is where comes our entire play of agents, right? Now, so we'll talk about agents, then we'll slowly jump into agentic RAG also. Now, why agent is important for us, right? So if you see, or why agents are important for us is, even if you see, Srini, can you show the diagram? Yeah, yeah. This is good, Srini. Because see, one or the other way of controlling the logic of computed AI system, which is nothing but this RAG system, is put into a large language models, right? So instead of relying solely on a predefined human scripted flows, you allow the large language to decide which module, or which another agent it can talk to, or what is the next function it can invoke as well, right? So this shift is possible because, as of today, I think most of us would be seeing, right, day in day out, there are so many models, large language models, coming up with better reasoning capabilities. By enabling these models to break down complex queries in the form of its own plan and interact with various external tools or even external agents as well, right? So now, if that is the case, oh, why do I need RAG? I could just simply go to agent, right? So why is this needed? No, it is definitely needed. So there's a difference over here. Meaning, see, the compounded system, which is a RAG which gets from all the documents and things, they are very fast, right? Because it has nothing to think. They think very fast because things are there. And you are telling it, saying, hey, just do this for me, and it will just do it for you. It's pretty straightforward. But whereas in an agentic system, right, uh, it's a slow thinker, because there's no path for it. It needs to break down, it needs to create that plan, it needs to see through what is it need to do next. It needs to think about a reason. So based on the reasoning, it needs to think about what is the next step it needs to do, and things like that, right? So definitely we need both the the agentic system, as well as the computed system. I think Srini's got some network glitch. Let's just give a pause. Okay, I think he stopped. I think possibly he's going to come back. In that time, if there's any questions, probably people can ask. Oh, over here. I'm just looking in the chat if there's something that you really want to, if you have a doubt how this is typically working. Okay, looks good then. Yeah. So definitely both the compounded how can we typically work on agents? Exactly. So Rakesh, that is what we are going to see. How we can work on agents. We are going to build an agent. We've already built it. We'll demonstrate the agent, and we'll see what these agents can do. And we will also see, is testing the right approach, right word, or is there something else? What are the things that we need to consider? Yes, definitely we're going to see how these agents typically work as well, right? Okay, so what are some of the common challenges when it comes to testing an AI-powered LLM application, and how testers can overcome that? Okay, so Rakesh, that's a very good question. So we're going to talk about that also. So whenever you build any applications based on LLMs, what are the key things that you need to consider, especially QAs, when you really want to test them, right? So we're going to cover that. That's in place for us. Uh, how is it different from 𝐾𝐻 AI? Okay, that's an excellent question as well. How is it different? So we'll also take that through, right? So till Srini comes, I'll probably cover that. So how is it different, right? See, like I said, agents can do multiple things. 𝐾𝐻 AI is an agent, right? You tell it to do, it breaks down, and it can think through. It will perform certain actions, and it's got a tool underneath, which is basically invoking. So 𝐾𝐻 AI as a agent, it is agentic. Now you can build your own agent. Let's say, for example, I'll just take an example, right? So let's say, for example, you want to build an agent based on your weather reports. So you might be getting some weather reports from some external APIs, right? And what happens now? You get the information from the weather report, and now you build an agent, which is basically a weather analyzer or something like that. So your weather agent can give that output to the your weather analyzer agent, and then weather analyzer agent can do something. So that's where I was telling, either it can basically hand over the information into another agent, and the other agent can do something, or it can also be another tool. So in our case with 𝐾𝐻 does not give its responsibility to another agent, right? 𝐾𝐻 itself is an agent now. So what happens? Basically, it gives it to another tool, and under the hood, there are multiple tools that basically it holds. Let's see, where is
I think
Srini?
we
Srini
can
just
take a
vanished.
couple of yeah, I think we can take a couple of
Questions.
more questions because seems like Shini's facing some network issues.
Yeah.
I think there is one question. Just give me a second. Let me just scroll up, please.
Okay.
Yeah,
I
I
see
think
one very interesting question. Sorry, Kavya.
go ahead, go
Uh,
ahead.
is
If you
the
saw it.
QA job is less once we move to AI? Definitely not, right? I think one thing I would typically tell is learn to live with it, because it's going to increase your productivity, right? So definitely QA's jobs will be there. It will not become less. All that we have to do is we'll simply learn to live with it. Let it be our assistant to save our 40-50% of our workload. So that way we all can live together very happily.
I can also
Srini's back.
see Shini here right on time. Awesome.
Yeah.
Great.
Okay.
I
Uh,
go to backstage now.
yeah. Yeah. Sorry, Kavya, I stopped you for the question which you wanted to pick. Do you want to take that and then we'll go? It's okay, Kavya. Okay, Kavya went backstage. Anyways, so Srini, I was just picking a few questions when you sort of dropped off. So I think we are good. I was just covering up some questions, very interesting questions in the channel. So Srini, where we basically stopped was we were just talking about why componented AI system and agentic both are very important, why they both should be put together and things like that. So maybe Srini, we can jump in because there were also questions like people are asking the chat, hey, how is this agent working? So are we going to cover all of that, and also we're going to focus on more on when it comes to agents, or when you build an application with large language models, what are the things to look at from a metrics point of view? So Srini, we can take out all of that now, Srini.
Awesome. So sorry about the disconnect. So I have a sample demo application built again, and all of the code is already
Srini,
available.
can you zoom in, Srini, and start?
Yeah, sure, sure.
Yeah, it's like
So the idea here is to showcase a simple application which helps us to chat with a PDF. So Sai was talking about RAG with specific additional documents, right? So I also have an additional document called appium.pdf. So this document was generated by Jonathan Lips probably around 4 or 5 years back. Appium has evolved since then. This document contains Appium's architecture. I mean, Appium when it was in 1.0 and now it is 2.0 and 2.16 point something as we speak. So there are a lot of things happened in Appium 2.0. And let's say we are doing a RAG on this specific document and a user queries for something like what's about Appium architecture. Then it gives me information from the Appium's document, which is appium.pdf. So let's quickly see how we do a RAG before we go into the intricacies of agentic AI. So here I am using OpenAI. You might have a look. So here we are using GPT-4, and the embedding model we are using is again from OpenAI, text embedding small. So these two helps us to do a reasoning for us. So before we do reasoning, Sai also spoken about. Okay, let me open the RAG. PDF. Sorry, Sai also has spoken about the important topic of RAG, wherein additional document goes to embedding model, and then the indexing happens, right? So, in while during the indexing, we also go through how does this works internally. Let me quickly scroll down. So here in this, we first read the document from the data directory, which is exactly what happens here. And then once the data directory is being read, we also need to store this chunk and store it into a local storage. So we use something called llama index here, and llama index provides their own local store called vector store. So vector store helps us to store this vector information, I mean the chunked information, into, it can be a PDF here, it can be some other images, it can be a MD file, or it can be a YouTube video. So it can be anything. For now, we consider PDF here. So the document can be chunked and stored next. So here is the vector store index provided by Llama index themselves. So what does it do is it performs the chunking, and one chunk and another chunk will also have relation. But we have taken the default one so that there is some relation between chunk one and chunk two. Like let's say last two lines or last two characters of chunk one is relevant to first two characters of chunk two of that sort in a very common language. Probably, let's say if a user queries for queries with an instruction. Let's say the query is what is Appium's architecture is all about, right? So the query comes in and the query engine comes in place. So the query engine fetches relevant documents or relevant chunks related to this query. What is Appium's architecture is all about. It goes and searches inside this vector store index, wherein relevant chunks will come up from the vector store index. It basically uses similarity search, and it identifies the similarity, I mean identifies similar documents in the vector store and returns us. So that is first. And let's say we are asking, another user comes up and ask another question called what's happening in Appium on 2025, whereas the document itself was created around 2018 or 2019, few years ago. and it doesn't have any information about what's happening yesterday. And let's say OpenAI, again, behind the scenes, it's OpenAI. So OpenAI doesn't know anything about what's happening yesterday in Appium or what's happening 2 days before in Appium on 2025. So the knowledge base is pretty limited. So it has to go ahead and do a Google search and then come up, right? So what we have done here to enhance the knowledge store here, we have introduced a Google engine. So we have introduced a Google agent. So that's next. So if you have a closer look here, we introduce called get Google results. So for fetching the Google results, we use two things. One, we use a node module called, let me quickly jump. So we use a node module called Google This, which helps us to fetch information from Google search. And two, this can go ahead and go for a task. It may not be able to fetch relevant information that we wanted according to our user's instruction. Let's say APM's happenings in 2025, let's say 2 days back. We don't know. Or probably Google might not be, I mean, the library that we are using may not be able to fetch relevant information. So what we also do, maybe let me quickly go deeper into the Google search. So we do Google search, it fetches the response, and as a fallback, we use something called 𝐿. So 𝐿 helps us to do a Google search for us. And another important part of 𝐿 is we also have provided where do you need to find the relevant information during a Google search. It is basically GitHub's Appium's GitHub org. So we also have specified the URL for it to do a Google search. So it performs a Google search on the Appium GitHub organization and fetches back the relevant results when performing a Google search. So first we try to extract this information, which is what's happening behind the scenes on Appium 2025. We try to fetch it from PDF, but unfortunately it won't be available. And parallelly, our AI agent, which is the Google agent, tries to search it from GitHub organization of Appium. So it will definitely find some relevant information there on what's happening behind the scenes on Appium, probably pretty recent information. So it fetches both these information and shares this information to LLM again to do a reasoning and see which one is very relevant. Sometimes we may get information from, let's say, if the user query is about Appium drivers. Even Appium 1.0 had Appium drivers. But there could be so many new drivers came in during the course of 5 years, and Appium architecture also has evolved a lot during the course of these 5 years. So it fetches, I mean, the PDF might give you relevant chunks which talks about older information. Google search will give you relevant information which talks about latest informations. For example, Flutter integration driver that we recently support in Appium 2.0, right? So these two informations will be fed into AI again, LLM model again, which is again behind the scenes, it's open AI's model. So if you see here, we get the Google response, Google results. Once after we got the Google results, we also have a final prompt which takes up both these informations. One is the PDF information, which may or may not found a relevant information depending upon the user query, and two, Google search information, and which is based on Appium's GitHub organization. And then it synthesizes both this information together and tries to figure out what is relevant, what is accurate. So based on this, it does a reasoning and provides us back the results. So this is where the one is the human scripted workflow, which is basically the traditional RAG. And here we are, I mean, and in terms of agentic AI or agentic RAG, we are letting the agent to do a Google search and provide us back with the relevant information. So the workflow is based upon, Google lets us know what it has to the Google agent that we have built lets us know what workflow that we have to take, either it is, whether it founds a relevant information or not. Depending upon it, it lets us know what relevant information we need to publish back to our users. And at the end, we also publish a citation, which gives us which source this information has came from, whether it's from PDF, whether it's from GitHub, or how confident it is based on the results it fetched from PDF or from the GitHub organization. So that's what exactly happens here. So at the end, chat with PDF, it's not just chat with PDF. So this agentic application does chat with PDF, and also if it doesn't have any relevant information, parallelly it fetches it from Google. I mean, basically it does a Google search as well, right? So that's all about chatting with PDF, wherein we have introduced a RAG, traditional RAG, and we also introduced an agentic AI. So let me quickly go through the test that we have so that we could check if it is all working fine. I have an agentic RAG test here. So basically, I'm just figuring out, I'm giving an instruction here and checks whether I'm getting the response. I'm not validating whether it is a right response or it is doing some hallucinations. No, I'm not doing anything here. Basically, my question is, what are the latest developments in Appium as of 2025? For sure, the document doesn't contain this. And let me do a quick run. So it goes back with this instruction and tries to see if there is any relevant document, I mean, relevant information. It does fetches something from the chunks. And parallelly, it is also doing a Google search behind the scenes and tries to fetch some information from the Appium's GitHub organization. So it does fetches something from the Appium release, what happened behind the scenes, what are the releases that we have made recently in Appium, and not just in Appium, also in the internal drivers as well. So it tries to combine both, it says both PDF and Google. Yeah. So it fetches exactly more of these information from GitHub. So we could see that it is trying to give me some information, although it may or may not be relevant. We need to evaluate what kind of response that we have received. In terms of agentic AI or any of these AI based AI enabled applications, it's not a testing. It no so I mean expected value. There is no one-on-one mapping here. It's purely based upon certain metrics. Probably, Sai, do you want to take us some of the metrics and let us know how this evaluation happens?
Yeah, sure. So, very one of the important aspects when it comes to applications built on LLM, and that you want to make sure. I think someone in the chat also, Srini, I was just trying to answer some of the questions in the chat as you were talking. I think one of the questions someone had also asked is, hey, how are we making sure that the output that the LLM is generated is not outdated, or in terms of whether it's right or wrong, right? I mean, it's a very valid thing, right?
Yeah.
So basically, when it comes to the LLM world, I think we should not use a term called testing, right? Because testing, basically what we tend to do is 1 equal to 1 or 1 plus 1 is 2, right? So if 1 plus 1 is not 2, we typically tell your test basically fails, right? So no, in the LLM world, we basically don't we don't do that. But if you remember, when we started up with this session, we were talking about the first document, we were talking something about a similarity search, right? So here there are different metrics that you need to consider when we are evaluating, right, what your LLM application is doing. And that's where you would be hearing these terms where people are talking about evals. There are a lot of frameworks which can do this, which can do these kind of operations, right? Meaning, instead of you testing it, you will evaluate the application, what kind of output it is going to give. I'll give you an example here. I'll take a real world example, right? So in one of my projects where me and Srini were working, I think a year back, not even a year back, it's like about 5-6 months back. So what happened was, it's an application built on large language model. And when any question is being asked, it's going to give us an answer, right? Now, how do you know whether that answer that the application gave is right or wrong, right? Me, with the domain context, to some level, with me not being an SME, I can tell that, okay, it is sort of giving me this. Now I go back to Srini being an SME, Srini will tell, oh yeah, this sounds okay. But I mean, I can't keep doing this for every test, every query, every prompt that I typically ask, right? So there has to be a system which can actually basically tell us all of this. And that's where this entire concept of evaluation comes into play, right? So if you want to put down a strategy, then basically it should be an eval strategy when you want to test applications built on large language models. So for this time, what we have done is, we have just taken very quick 3 matrices over here, which Llama Index default gives us, which is faithfulness, correctness, and relevancy evaluator. So basically, what each of these would typically do is it would basically get your output. Let's say you have a front, you have a application, you ask a question, it's going to give you an answer. Now it's going to take that answer, and from that answer, what is it going to do is you need to write a test framework for that, basically, where it will actually give it to a critical LLM. So you can call it a judge LLM or a critical LLM, whatever. So right. So that's going to be a different model. So let's say if your application is working on GPT-4, so maybe a critical LLM could be a 4 mini or a 3.5 turbo, whatever, right? That is, doesn't matter. Then what happens is, so basically an output generated by one LLM, well, one large language model, will be evaluated by another one. Okay. You could still ask, hey boss, you are again still going to an LLM, which is a large language model. So what is the trust factor here for us? So there are evaluation tools like Ragas, Giscard, there are Trail, there are multiple things which can do that, where the entire approach would be such that you basically create a golden data, right? A synthetic data / golden data, right? So you can call that also as a ground truth over here. And so you talk to your SME, tell the SME, hey, for this question, I need an answer, right? That's good enough. I didn't need anything more. Now, what happens is, so you already have an answer from your SME. So that's your source of truth, right? It's golden data for you. And when you are running your automation against these critical LLMs, basically you can take that answer and send it to these matrices that we are talking about, right? Like to check whether, hey, can you check what is the correctness of the answer that I've received from my application with the answer that I actually had. So it's going to throw some kind of a matrix for you between 0.0 to 1.1, meaning for you, what happens, between 1. So that's like 10% to 100%, right? So if it's, let's say, 0.7, so it's like 70% accurate for you, right? So you have to decide based on your project whether you want to keep it 70% threshold, 80%, 75, and etc., etc. That's exactly what we have done even in this test over here, when you see. So we are basically looking at certain metrics like faithfulness, correctness, and relevancy scores. And if Srini could scroll down over here, we could have also set our thresholds. Right, that's basically our responses that we get. Look over here. So we are setting a threshold to say, if for this question, the answer that my application gives, the score should be at least 70% for me. Right. This is something what the critical LLMs will take care for us based on the golden or the synthetic data that we provide. Right. So always when you are testing an application for based out of LLM, think about evaluation, not about testing. Right? There are frameworks also. This Llama index is giving only very few for us, but if you go look at Ragas, there are a bunch of them it's got. And if you go and look at Giscard, there are a bunch of stuff it can actually give you. There are a lot of matrices that are involved. But we have just written this in TypeScript. Those two are in Python for us. So it doesn't matter. It's just a framework for us in that place. Right? Srini, do you want to add anything, Srini? Or we're good here?
Yep. I just ran our test, and our query is mostly irrelevant here, which is about RAG architecture. And we are asking about RAG architecture from the PDF. It doesn't have anything about RAG, and it doesn't know anything about RAG. All it knows is only the Appium stuff. And based on our evaluation, what it has returned is basically 0, whereas we are expecting around 70%. And not just these metrics, we also have other metrics. So some of the other metrics that we evaluate our system was on: what was our latency, how many times we have reached Google, what was the source of truth, how is it, and what was the token count, citations, how many times we attempted to do a Google search, what was the errors that we have received back, and what was relevant and what is irrelevant. So we do have so many other metrics that we capture upon. And some of the three things that comes by default is from Llama index is fairness and correctness and relevancy. There are a lot of other matrices. For, as I said, there is other tools like deep eval, there is Ragas, which is widely used in industry to evaluate how does our response looks like. So, in terms of agentic AI, observability plays a crucial role. Although we do evaluate for a lot of our instructions that we prepare upon, but everything comes out of box. When we put this in a production, the user may query or ask about something which is very irrelevant, that we have not added in our instruction all about, right? And our agentic AI application that we have built might go for a task for certain kinds of instruction. So it is always important to know when we put these kind of systems, as like how we put a traditional system in production and observe how user interacts with our application. It is more important here, because the instructions might be uh, different for Sai, different for Srini, different for you, different for others. So it is important to know how it is being used, how it is being consumed, whether it is doing hallucination for certain kinds of instructions, or we are getting certain instructions which doesn't, I mean, which our system is not capable to do, or it could be a valid instruction, but our system is not able to perform or serve those instructions. So putting an observability system in place, although we have traditional RAG or then agentic RAG, keeping an observable, monitoring and figuring out what kind of instructions coming in and what kind of response going out is really important here in our case. Yeah. So some of the other metrics as well. Okay, I did ran a few tests. I mean, just one test. There are plenty of other tests that are available. So we do for different kinds of queries that we have, as I was talking about. When we measure these metrics and figure out how much tokens we consumed, how much of the source being consumed from PDF, how much it is consumed from uh, the Google search or the Google Agent AI that we have built as well. And quickly going back. So this is the minor. I mean, this is the difference between the traditional rack and the agentic rack. Again, credit goes to the Avi Chawla for preparing a wonderful doc on agentic rack. So this helps us to fetch information from. It could be in our case, it was a Google search, but it could be in any tool. It could be an external endpoint. It could be a different tool altogether, which performs different kinds of workflows, and based on that, the decision happens. So here we are not scripting the workflow to do only certain thing, wherein we introduce rack and agentic rack. It helps us to do not the human scripted workflow. It helps us to take certain important decisions based on what it thinks is best, relevant, and accurate as well. And these are some of the other matrices that we were talking about: faithfulness, similarity, response relevancy, how well it is relevant to the query that we have initially asked for, context precision, chunks that retrieved. So there are a lot of algorithms like similarity search. There are a lot of other algorithms. Which algorithm is pretty much useful for the particular use case? That's also required. There could be instruction tuning, or there could be the chunking. Chunking might have its own strategy, which can help us to provide relevant context as well. Yeah.
And I know, Srini, a lot of questions. Yeah, right. When we're talking about agents, people are trying to relate, agent with very close to testing, right? I think in the recent times, one good example that I can give, agent in the space of testing, I think browser use, right? Some of you, if anyone's missed out, then probably I'll just quickly put it in the chat. So browser use itself is an agent, right? And the responsibility of that agent is, you just tell me an instruction and I will go do that for you. Basically opening a browser. Let's say you can say add items to the cart in Amazon.com, right? So you are giving it, you're just telling it, do this to me. And it looks at the screen, it's an agent, it can start thinking, it can reason, it can do a lot of things, right? So this way, there are me and Srini wanted to introduce you to what are agents, how you can build an agent, and if you are building an agentic RAG very specifically, then in that space, how do you evaluate it? Not test it. How do you evaluate it? That's very important. That's what we wanted to cover. But I see a lot of questions going around. Hey, can I do load testing? Is there a agent for doing load testing? Right? No. So now that's where I said one good use could be a browser use for you to understand from a testing space how agents can be built. right? So one agent possibly that me and Srini are sort of thinking that we can also build is something like you just tell something, build an mobile agent, let's say for example, right? And let's say mobile test agent, like what browser use can do, and basically you just let it to think, decide, plan everything for you, and under the hood, the tool it can basically use is basically Appium or Selenium. So browser use possibly is using another tool under the hood and things like that. Right.
Thank you so much,
Yeah.
Sai and Srini. So we
Thank
have a
you.
couple of questions, and I wanted to make sure that we are taking up those questions. We have 5 minutes before the next session. So quickly onto the screen, I'm just bringing it up. Yeah. So this is from Damini. How do you ensure the reliability and accuracy of AI agent responses across different scenarios?
So I think, I mean, at the end, that's where we were talking about, we were talking about evaluation aspects, right? So always try to get your golden truth data. We only showed you few metrics over here. There are a lot of other metrics as well. And what you can do is you don't have to implement all of those metrics as well. So talk to your team, see what are those metrics was, which is very important to you. Let's say, for example, faithfulness, you don't want it to hallucinate if that's what you want to do, and the correctness, similarity search, right? Even if my answers are similar, like 80% similar, it is still good for me. So if I ask about India Pakistan match or anything, it should relevantly talk about that, not just go talk about NBA, right? It doesn't have any similarity on a whole. So always bring that entire eval perspective into it. Don't leave everything to the LLMs. Then you don't know, right? One LLM is your application which is bringing you an answer. You go to another LLM also for it, it might just mess up even when you're generating your test data. Always make sure that your generation of the test data is still intervened by a human, validated, and then give it to these LLMs so that these kind of metrics can be captured.
Awesome. So bringing up the next question, how is vector database designed and what are the components involved in it?
So here we are using in our sample query, right? Here we are using an in-memory vector database where there are a lot of vector database available. The one that I have used extensively is Pinecone database, wherein they have a lot of wonderful suggestions about how it has to be designed. I would rather let you explore that from the Pinecone, which is really amazing in terms of designing a vector database out there.
Picking up the next question, which is from Vishal, who wants to understand, can we create agents which can be used to do all the repetitive tasks and handle the workload so that as a QA, I can overlook the final reports?
Absolutely, Vishal. I'm thinking what possibly can be an example here, right? So meanwhile, Srini, if something pops in your head, go ahead.
Yeah, so when I see reports, right, the less validated place is mostly around. We do execute quite a lot of things every now and then in our CI, and someone has to sit and go through what's happening there and why it has failed and what exactly happened in Appium server logs. Right. Another important place probably is to introduce a reporting agent to go ahead and analyze what is Appium log says. And then if it doesn't have a construct, let it go ahead and do a Google search and figures out what does that exact error means and gets back to you with the response. So this could be another agent wherein helps you to reduce the manual time in terms of identifying why Appium throws such kind of error.
Yeah, I can think of one more is possibly an agent which can pull information from Jira, integrated with Jira. And if there are enough information, possibly it can just write your test cases for you. I'm not saying it'll be accurate. At least it will do 50% of your job by writing those scenarios. You can validate it and just keep tweaking it based on your knowledge, right? So that's another area where these agents can come and save a lot of our time. And that's where I said the jobs are not going. You need to learn to live with it, take assistance from it so that we all can survive over here.
Thank you so much. I think we can take one more question before we wrap up, which is from Priyada, who wants to know about what are the best practices for testing LLM applications to handle bias and ethical concerns.
Yep, observability plays a crucial role. So some of the best practices, I would say, based on our experience working on different consulting experience that we had in past and now, is observing how does your system behaves, especially for these ethical and bias concern. We may have some bias while doing a testing, which is itself is a wrong. And on top of it, we may think that everything is well and good before we put that in production, but the instruction that user might be using to access your application and derive some data out of it might be completely different. So to understand how users use your system is getting more critical and critical than traditional applications in terms of the agentic application. Sometimes we may need to understand the instruction and try to serve that instruction back with a very good data response, but we may broke the normal instruction end of the day. So having a huge range of instructions, how your application is being utilized in production gives you a better confidence level. Again, we can't say it's 100%. There is no 100% here, and we can say that we are able to serve this many number of requests in a very I mean, in an unbiased fashion, I would say.
Thank you so much, Srini, and thanks a lot, Sai, for an amazing session. It has been super engaging. I can see a lot many questions and comments in the chat. I would request all our audience to get in touch with Srini and Sai over LinkedIn or Twitter. Both of them are pretty active on LinkedIn as well. Feel free to also send an email to conferences@lambdatest.com if you have questions that went unanswered, and we can help you get the answers or connect you with Shini and Sai over there. Thanks once again, everyone. On to the next session. Have a good day.
Thank you.
Thank you.
Thank you. Thank you, folks. Thanks for joining.